We're covering atomic structure and the periodic table for the AFOQT physical science subtest. Understanding these fundamentals is non-negotiable for a strong score. First, let's break down the atom. At its center is the nucleus, containing positively charged protons and neutral neutrons. Orbiting the nucleus are negatively charged electrons. The most critical number to know is the atomic number, which is simply the number of protons. This number defines the element. For example, any atom with 6 protons is a carbon atom, period. The mass number is the total count of protons and neutrons in the nucleus. The AFOQT will test your ability to differentiate these. A common question might state that an element has an atomic number of 17 and a mass number of 35. Then ask for the number of neutrons. You simply subtract the atomic number from the mass number. So 35 minus 17 equals 18 neutrons. Now, let's clarify two commonly confused terms, isotopes and ions. Isotopes are versions of the same element that have a different number of neutrons, and therefore a different mass number. For example, carbon-12 has 6 protons and 6 neutrons, while carbon-14 has 6 protons and 8 neutrons. They are both carbon, but carbon-14 is a heavier isotope. An ion, on the other hand, is an atom that has gained or lost electrons, giving it a net electrical charge. If an atom loses an electron, it has more protons than electrons, resulting in a positive charge, and it's called a cation. If it gains an electron, it becomes negatively charged and is called an anion. The exam will try to trick you by asking to identify the relationship between two atoms, one with a different neutron count and one with a different electron count. Remember, neutrons mean isotope, electrons mean ion. Next, we have periodic trends, which are predictable patterns on the periodic table. The two most important for the AFOQT are atomic radius and ionization energy. Atomic radius refers to the size of the atom. As you move from left to right across a period, the atomic radius decreases. This is because you're adding more protons to the nucleus, which pulls the electrons in tighter. As you move down a group, the atomic radius increases because you're adding new electron shells, making the atom larger. Ionization energy is the energy required to remove an electron from an atom. It follows the opposite trend of atomic radius. As you go across a period, ionization energy increases because the tighter hold on electrons makes them harder to remove. As you go down a group, it decreases because the outermost electrons are farther from the nucleus and easier to remove. A great way to remember this is the snowman rule. Picture a snowman. As you go down, the sections get bigger. Just like atomic radius increases as you go down a group. For ionization energy, just think opposite. The exam loves to present two elements and ask you to compare their size or ionization energy. For example, which is larger, sodium, Na, or chlorine? They are in the same period, and since radius decreases left to right, sodium is larger. Which has a higher ionization energy, fluorine or iodine? They are in the same group, and since ionization energy decreases as you go down, fluorine has the higher energy. Mastering these definitions and trends is key to acing these questions. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.